down next to the table.
Yeah.
Okay, and then slowly down. So what have we got? Some more stuff from...
Yeah, this is a special delivery that came in earlier this week. Another donation from Wessex Archaeology. On this occasion, it's items that have been dredged up in Portsmouth Harbour to prepare the berth of the new Queen Elizabeth class aircraft carriers.
Fantastic.
They were dredged up a few years ago. They've been held in storage and they were offered to Fort Amherst, and we have gladly taken them. It consists of one rather large shell in this box here, which we were struggling to get out of the artefact store earlier. I'm not sure the calibre, but looking at that, I think that's going to be somewhere around sort of 6 inches. See if we can work this out. The calipers around it.
So what's the purpose of doing this?
This will determine sort of what type of shell. We know it's a solid shot shell, but it will tell us what the calibre is. So we've got the calipers, so if we get the tape measure, we can then measure the gap in good old-fashioned inches. And it's actually so just it's 5.5, isn't it? I think that's it.
So that's probably 6.
No, 5 1/4. Sorry, 5 1/4. 5.25, which actually is a recognised calibre, British calibre, 5.25.
Yes, and that sort of the slight twist on the shell. What's that?
That's the rifling. Now this shows it's quite an early shell by the fact it has this old style rifling which goes almost the full length of the shell, so it engages with the rifling in the barrel of the weapon, and it causes it to spin as the speed picks up. By the time it gives it an accurate projection, increases the accuracy quite considerably against the much earlier sort of cannonballs that we use. This is a solid shot projectile, which means it's for punching holes in armour plate on warships. So we know this dates from probably about the 1870s onwards. Yeah. And I would say before about 1885, and the fact that on this type of rifling. So this is quite an early rifled projectile.
And when we think back to the training round that we saw in other shows, this here wouldn't actually be loaded like that, would it? It would go in and then a propellant charge?
Yes, because of the size of it, you would not have a shell casing with it. You would put the shell in first, you'd put some wadding behind it to make a seal, then you'd put the cartridge, which is the explosive charge, to propel it. Yes, then we have some other items that turned up in these white containers. Now this is a cannonball.
I stress these are very heavy.
They are extremely heavy. And that's 7.5 inches.
Yeah, 7.4.
Now, think about these cannonballs. You can.
That's over a 42-pound ball.
Right. So the nearest calibre to it is 42, is it?
Yes, on this chart.
Now, on British cannonballs, the next size up from 42 pounder would be 68. So this is probably then a 42, but the weights were not precise. You know, there was variation on it. So we can say this is 42. This is one of the largest calibers of smoothbore cannon.
And this would be the type of shot fired by the Victory, would it?
The Victory would have fired similar types of cannonball. Yes, they would have fired from quite small to 9-pounder right up to 68-pounders, which are a huge different range of cannonballs.
And you've just got to think about what the damage that would be going through wood and shit. I mean,
that would smash through the oak sides of a warship. You know, 18 inches of oak that would actually go through at certain ranges. And the real devastation it's caused is actually the splinters that are shattered on the inside of the vessel. That's what causes the injuries to the men, rather than being hit it'd be a rarity actually to be hit by the actual
Well, it might
cannonball.
be a small mercy.
Yeah, it may well be, yes. But it was the splinters that did the damage. Now, this is quite interesting. Well, it is a cannonball, but the thing that's interesting is this shows you what happens when you allow it to dry out.
Yes.
When cast iron is left in sort of salt water, the salt leaches into the metal. As it dries out, what happens is that the salt crystallizes and it then starts to peel away the metal, right, like a laminating effect. So you can see here his outer side is starting to come away.
So it's like a sort of freeze-thaw process.
Yes,
Where the crystals form underneath.
and for a couple of years it might seem absolutely fine, and then once it dries out completely, the salt just literally breaks it away. Eventually this would go down almost to nothing if untreated. So what we're going to do with this, we will put it into a chemical solution today that will help to stabilise that.
Excellent.
It's like it's been eaten away. This is probably by marine sort of life of some sort.
So the sooner we can get these in the
Absolutely,
bath, the better.
yes. Actually, we've got some of the details there. Portsmouth dredge, cannonball. All they've done is put an M, they'd say medium. But we've got a date there, 2015. So we can say this has been out of the water for the best part of 6 or 7 years. In fact, all we've looked at so far will require conservation treatment. And again, we have cannonballs that are suffering from deterioration.
Let's see the calibre on that one, Arch.
If I had to put a guess on there, I'd say somewhere around about a 12 pounder. But okay, let's do the measurement. Exactly
Yeah, 5.
5 inches.
5 inches.
By the magic of Mr. Google,
£18.
18 pounder. I was 6 pounds out. This one has the look of a 24 pound. Yeah, it's lost some of its integrity.
And there was probably a limit to how accurate they were at the time, right?
Yes. This is a good 6 inches.
Yeah, 6.
Ah. Yes, it's 6.1, it's 32 pounds.
32. So again, I'm underscoring on this.
That's quite a big one, Keith.
It is indeed. We can get it on the undamaged side.
Yeah, if you measure across now.
Looks like it's going to be about 6 inches again, doesn't it?
Unless it's
Yeah, 6 inches.
6 or 6.1.
So that makes it 32?
Yeah,
Yeah,
32.
32.
Yeah.
So we now need to think about printing.
We do indeed, yes.